Hey guys, this is Dr. Strout, and I had one of your classmates ask for more explanation about supply and demand and wanting to know more about what these curves meant and kind of where they came from. So I'm doing this video so that I can be face to face with you guys. It's hard for me to teach without drawing the graphs as you're drawing them and without explaining it face to face. So hopefully this will be a good substitute. So let's start with looking at where the curves come from. So I'm going to pick a product that most of us love, and that's pizza. So let's talk about the supply and demand of pizza. So excuse my rough graphics. I'm in England as I'm recording this, but I'm going to use paper to try to draw this for you. So first off, let's talk about these axes. So these are going to show us two different things. The horizontal axis is always going to be our quantity. And in this case, it's the quantity of pizzas. The vertical axis is going to show us our prices. And the different quantities that we wish to buy at different prices will create our demand curve. So let's pick some prices to label on here. You could do it by fives, you could do it by tens. I'm going to do it, let's do it by fives. So let's suppose we have pizzas at $5, pizzas at $10, $15, $20, $25, and so forth. Okay, don't know if you can see those numbers. I've just got 5, 10, 15, 20, so forth. So we're looking at pizzas. Now, what's important is this bottom corner here is always 0. That's always where you have no prices, so it's free. Although, right, free is not a word we can say in economics very well. And it's also where you have 0 quantity. So if I draw with the quantity at 0, that means nobody is either buying if it's demand or nobody's selling if it's supply. This will make sense hopefully a little more as I start to put on the supply and demand curve. All right, then we have quantity. Let's just suppose we're looking at everybody in this class. So there are roughly 30 of us, and we're looking at how many pizzas in a week would 30 of us want to buy. So let's have this increase by tens. Again, it could be by ones, it could be by hundreds. I'm just going to have it by tens. It doesn't matter what quantity. So if you wanted it by ones, you could draw 10 little dashes in between. So 10, 20, 30, 40, 50, and so forth. All right, so this is our quantity. I guess it's possible we would want more than 60. We're going to, let's go ahead and add 70, 80. I like pizza. 90. All right, we'll have all these on here. So what we want to do, it if we were in a face-to-face class and I had pizzas available, I'd actually auction them off. But I think it'll make sense if I were to ask everybody, even just to think about it, how many pizzas do you want if they're $30 a piece? So this top price up here, $30. At a price of $30, how many pizzas would we buy? Maybe one person would buy a pizza. They're desperate for pizza. So very few people would want to buy a pizza at 30. So I'm going to do 30 and suppose that's 2 pizzas at 30. So that's 1 point on our demand curve. So 30 is our price. So I'll go over at 30 and then dot down to we're about at 2 people who are buying pizzas. Or it could be one person buying 2 pizzas. So $30, we're not going to sell very many pizzas. If the price fell to $20, well, maybe now, I don't know, maybe most of us would buy, half of us would buy 1 pizza a week, let's say, at $20. So I'm going to go up to about 15 and over to 20. So 20 is our price. So I'm going over from 20. 15 is our quantity. So I'm going up from 15. And this is another point on our demand curve. Now, each of these points on our demand curve shows us the quantity demanded at the different prices. Okay, it's the curve as a whole is our demand. Each of the points is quantity demanded. Now, as the price continues to fall, so Domino's realizes they really need to lower the price. They're not selling enough pizzas. They're running a special. It's buy one, get one free or whatever. And so now the price of pizzas, let's say, is $10. Well, now all of us will buy a pizza at least once a week. So we're going to be at 30 pizzas. And if the price fell even further, maybe the price fell to $5, maybe we'd all eat pizza twice a week. And so we'd go over to $60. Again, I'm assuming there are 30 of us. That's just using this for an example. The point I want you to see is that as more and more people are buying pizzas, it must be the case that pizzas are falling if our quantity demand is increasing. That's the law of demand. So as the price of pizza falls, the quantity demanded of pizzas increases. And conversely, as the price of pizzas goes up, the quantity demanded of pizza will decrease. Now, I've given you a few example prices. What if it was $25? What if it was $8? Does it make sense that these points in between here are also possibilities for items that are demanded as well? So, all of these points together make up our demand curve. One point represents the quantity demanded at a particular price. So this point is the quantity demanded and our quantity demanded is 60 at price equal to $5. Hopefully you can read that. Sorry, my handwriting's not the best. What that says is that the quantity demanded is 60 at a price of $5. With this point right there, that's what that point represents. Now, let's suppose that a study comes out that says that eating pizza, let's be optimistic, eating pizza is great for your health. I don't know, probably not, but let's assume it does. Let's suppose that a study comes out that's saying pizza has all the food groups and it's really good for your health. Why not make that assumption? It's more fun than the alternative. All right, if that's the case, then does it make sense that even at a price of 30, now a few more people are willing to buy pizza? And so quantity demanded at 30 now is a little higher. Quantity demanded at 20 also is now a little bit higher. At a price of 10, now instead of everybody ordering one a week, maybe we eat it 1.5 times a week. So quantity demanded might rise even more. And likewise, at $5, maybe quantity demanded is way out here. So once we have the study come out, that means that at every price, our quantity demanded is higher. And so what we have is, I don't know if you can see the orange there, a new demand curve. So going from here to here, what we've had is an increased demand. And that means that the curve has shifted. And if it increases, it shifts right. Okay? What are some other things that could cause demand to go up? Well, maybe Western has a higher enrollment, and so we have more college students. That would cause demand to rise because college students like pizza. So maybe it's an increase in the population. All right, here we've got a change in taste. You know what, I'm not going to write it because it's going to be hard for you to see, but I'll write that one. Change in taste. Maybe it's an increase in the population. Maybe it's an increase in income. Now, if incomes go up, it depends what type of good pizza is. If pizza is a normal good, then demand for pizzas will go up. Normal goods are goods that we demand more of when we make more money, whereas inferior goods are goods that we demand more of when we make less money, when our income falls. So your book, I think, talks about ramen noodles as an inferior good. The poorer we are, the more ramen noodles we have. Oh, sorry, I've got a child wandering around in the background. The poorer we are, the more ramen noodles we eat, and more income could lead us to eat more steaks or restaurant meals or, I don't know if pizza is a normal or inferior good. You can decide. We'd have to look at the data to figure it out. So if income changes, that can change our demand. If the population changes, that can change demand. If there is a study that comes out that says that, like I said, pizza's healthier or less healthy, that'll change our demand. If the price of a substitute changes, so what's a substitute for pizza? I don't know. Mexican food's my favorite substitute. So if the price of Mexican food goes up, my family's going to order more pizzas because I see pizza and Mexican food as substitutes. I don't typically eat them together. I eat one or the other when I'm looking for a meal out. So if the price of a substitute goes up, let me write this down. there's an increase in the price of the substitute, that's going to increase the demand for the other good. Because now I'm going to substitute away from away from Mexican food and buy more pizza. On the other hand, complementary goods. So breadsticks and pizza go together quite well. Maybe you like soda and pizza. So if the price of a complement were to go up, now it's more expensive for you to buy your breadsticks or your Coke to go with your pizza, then you're going to buy less pizzas. A better example of a complement would be something like peanut butter and jelly. So peanut butter is more expensive. I don't need to put jelly in my cart because I'm not buying the peanut butter. Therefore, I don't need the jelly. They're complementary goods. I eat them together. Whereas substitutes, I eat one or the other. So prices changing in substitutes and complements can affect it. There's another factor that changes that the book talks about and we talked about, which is the price that we're expecting the good to have in the future. So if I expect the price of pizzas to be falling in the future, I'll give you a great example. Yesterday I was craving pizza, and at the Harlingen College where I'm at this fall, there is a special at Papa John's, buy one, get one free on Tuesday. So on Tuesday, essentially the price of pizza is half price. So I expect the price to fall in the future. That means that my demand for pizza on Monday is lower. It falls because I expect the price to fall in the future. Does that make sense? So it's the expected future price. If you expect something to go on sale in the future, you'll hold back and not buy as many at every price now. Okay, so that's demand. Demand shows us all the different quantities demanded at the whole range of prices. So how much do consumers want at the whole range of prices? That's demand. If demand is changing, something other than price must change. Here's a good hint for your test. If the test says that price has changed, which of the following will result? It's not going to be that demand's going to change as a result of price changing. Now the reverse can occur. But for price changing, it won't lead to a change in demand. It'll always lead to a change in quantity demanded or quantity supplied. Okay. Next chapter, we'll talk about how the reverse, though, can happen. When demand changes, it leads to a change in price. And when supply changes, it leads to a change in supply. All right. Now supply. Supply is the producer side. It's the same graph setup. It's going to look different, though. Our supply curve, when we graph it out, we're going to have it being upward sloping. And here's why. How many pizzas will Domino's want to supply at a price of $5? At a price of $5, they're not going to want to supply very many pizzas. They don't want to sell many at $5 because it's not worth their time. It's not worth their hiring all these workers and all this. So there will be very few, and maybe it's hard to think about Domino's wanting to sell less pizzas, right? Because they're already open, they might as well sell pizzas. But how many pizza chains will you see opening up, selling pizzas in Bowling Green if the price is $5? Very few, right? As the price goes up, you'll see more and more pizza chains start to open up. And so at higher prices, more and more people will be willing to sell pizza. And so the quantity supplied, this is still quantity, this is still price. The quantity supplied goes up as the price goes up. So maybe this is 50, and maybe up here at a price of $20 a pizza, you see, what's that, roughly 70 people. I'm making up the numbers in the bottom, but the point that's not made up and the point that you need to know is that supply has this upward slope because as the price goes up, it's now worth it to more people and even worth it to the one person like Domino's to sell more pizzas and shift away from other goods. So now instead of trying to sell all these products, maybe at the higher price pizza, they're just going to focus on pizza. Okay? That's a supply curve. And there's similar law of supply that argues that as the price goes up, then you see an increased quantity supplied. All right? That QS just means quantity supplied. Likewise, a point on the curve represents the quantity supplied at a particular price. So this point, we'll call this point X, this is the quantity supplied of pizza at a price of $10. All right, now let's suppose something changes. Let's suppose the price of tomato sauce falls. Tomato sauce is now cheaper. Does it make sense then that at every price you will see more and more pizzas supplied? So I'm going to go from S1 to S2. This is an increase in supply. So no longer is this what's happening. Now we're looking at an increased supply due to a decrease in the price of an input. Our example was tomato sauce got cheaper. That just says price of an input. As tomato sauce got cheaper, we saw more and more pizzas being supplied because now it's cheaper. And so more people will enter in and supply this good. And even the firms that are producing this good will be willing to sell more and produce more at lower prices. So supply's gone up. All right, what are some things that can cause supply to change? Essentially, anything that changes the price of producing is going to change the supply. So if it becomes cheaper or more expensive to produce. So it could be technology changes, it could be efficiency changes or productivity changes, it could be natural disasters that destroy productive capabilities, it could even be prices of inputs, minimum wages going up, or average wages going up, or if the ovens become more expensive or electricity becomes more expensive, or here's a big one, if gas becomes more expensive, we expect it to have the biggest impact actually on supply because transporting those goods now is much more expensive. All right, so that's supply. Now, we have not yet put these two together, but I think this will help you see why it matters if I go ahead and put it together. You won't be tested on this next part on this test, but it'll help you for what's coming up. So essentially what we will do is we will put supply and demand on that same graph. Remember, the axes are the same. Here's our quantity. Here's our price. We're going to put these on the same graph so that we can figure out how many pizzas are going to be made in Bowling Green. Wherever quantity demanded equals quantity supplied, that's called our equilibrium. Okay? Quantity demanded equals quantity supplied, that's our equilibrium. And that determines our equilibrium. Sorry, I'm trying to draw this from abroad. This is their equilibrium quantity, which we'll put a Q star, and our equilibrium price, which we'll put a P star. This is our equilibrium. And what we'll talk about next is what happens when something changes. So if there's a hurricane that destroys a lot of factories, for example, and supply starts to fall. Remember, supply falling, shift to the left. Demand falling, shift demand to the left. Increasing, shift to the right. And I tell my students, usually in my face-to-face classes, think of your favorite dance song, right, to the left, to the left. So whatever shift to the left is for decreasing, to the right is for increasing. So my supply has been drawn to the left. This represents supply decreasing, in this case, because of a hurricane. So the supply of pizzas has fallen from the hurricane. We can't get the tomatoes. We can't get the marinara. Everything's more expensive. We don't have all the facilities to make pizza. Supply has fallen. And what we'll talk about next time is what impact does that have on our equilibrium? And these graphs are going to be huge to help us figure out what happens to equilibrium. I would recommend, as you're taking your test the next time, not necessarily this time, having a blank sheet of paper so you can draw it out. Because what we'll see is if we draw it out, it'll give us the answer. So rather than being down here at P1 where we were, now we're at P2, which makes sense, right? If a hurricane destroys tomatoes, we don't have access to the marinara, prices of pizzas are going to go up. And fewer pizzas will be sold. So our quantity in equilibrium will fall. The quantity demanded and quantity supplied where they're equal will now be lower. All right. This will be helpful as we start to think about what can firms do to sell more. Also, when we start to think about what is the effect of different actions of Oprah Winfrey coming out against beef. Why did the cattle farmers get so upset? And we can talk about what's the impact on the price that they can sell their beef at now, or the amount of beef that they're selling. Or what's the impact of a movie star wearing this brand of tennis shoes, and now everybody wants those tennis shoes. What impact does that have on the market for tennis shoes? So this will help us to understand what's going on in the markets around us. Hopefully that's helped give you a little bit more clarity. As always, if you have questions, feel free to shoot me an email. Take care.